Should we start on time? Probably yes, because of the report.
Yeah, I think you can start on time. I can go see if there's anybody in the hallway. Hi, everyone. Lunch will be slightly delayed, but it will be here around 12:15. I'll go see if there's anybody outside that wants to come in and maybe start a couple minutes late.
We'll start.
Okay.
Maybe we should close the door, I guess,
Yeah.
for the noise. We will start shortly.
I'll just sit down here in the front in case you need me.
There's a technical problem. Yes. Should we be starting? So I would propose that we start, right? Because just to be on time, because I would like to have some time for questions if possible. So my name is Wim Henderickx. I work for Nokia. So I work for VATCH that you saw yesterday on the plenary. The goal of this talk is to give you some insights what we are doing with respect to cloud native automation. So my goal of this session is to give you actually an overview of Nephio. So Nephio is an open source project that we are doing where all of this is being developed, right? So, and my goal of this talk is to give you some insights, what we are doing, how it works, and so on and so forth, to share some knowledge and so on and so forth. But before I start, how many people here have been or have heard about Nephio? Okay, so it's quite a few. And how many people are familiar with Kubernetes and that ecosystem? Because yeah, I didn't know, so I prepared a few, so quite a bit. So I prepared a few slides to give you some context because all of this happens within the context of Kubernetes. So I wanted to, I didn't know what to expect. So in the presentation, there is a little bit of information on that as well, just to give you some context. Now, so as a start, what we are trying to do in Nephio is actually, so this is actually a screenshot from the website. So what we are trying to do is to deliver what we call a carrier-grade cloud-native automation solution. The use case that we are focused upon right now is actually network function deployment, so 5G and so on and so forth at scale. Now, what you will see, or what I will trying to do during this presentation, a number of the things that we are doing with respect to the automation tool chain is not constrained to the use case, right? So keep that in mind, but I will use that use case to illustrate the primitive that we are using within Nephio to do that automation. But the use case as such, so the solution as such is not constrained to that use case, right? And I'll try to explain that in probably a little bit more detail when we go through the examples and so on and so forth. But so what is important here, what we see is that we are actually extending Kubernetes, right, with a number of primitives to achieve that. And so the use case is important because what we don't want to do inside of Nephio is reinvent everything that has happened within that ecosystem. We are trying to augment things that are not yet available there, right? And as such, we are trying to augment capabilities and give you capabilities to ease that automation within that environment, right? Now, one of the primitives that we have is we have to do that at a pretty large scale. So in other words, for us, the unit that we work with is not just a single cluster, but it's actually a fleet of clusters, right? And you will see that, that in a bit. First of all, this project is not a Nokia project, so it actually got initiated by Google, and it's sponsored by Google. There is a number of, let's say, vendors, system integrators, as well as service providers involved, because what is important is that this is actually an area that is important, or that all these parties need to be involved in, right? Because we can come up with a great automation framework, but unless the vendors adopt it, and secondly, the service providers implement it, it has no use, right? So, and as such, it's critical to have that landscape of people that are involved in this space to get insights on how they are using or what they are using, and secondly, trying to identify the gaps that we have and try to improve those as we go along, right? Also, this is, yeah, I forgot to mention, so all of this happens in LF networking. So this is a Linux Foundation context, right? And so everything that I'm talking about is actually open source, right? Now, in order to achieve that, and I mentioned that we are using use cases and user stories, right? And we are doing reference implementations, right? So all of what I'm talking about here, you actually see in code, right? And you can actually experiment yourself with within that environment. And in order to prove that, we are using reference implementation, and one of those reference implementation is FreeFive-GC. So FreeFive-GC is an implementation of a 5G core. So you have for those familiar with the terminology, you have a UPF, an SMF, and an AMF, and you have an NRF, and so you have the whole framework there. And we are using that to prove that use case. We also started to provision infrastructure, so we are provisioning clusters and so on and so forth. So there is an implementation of Cluster API, which is a Kubernetes project. And so we are using that to actually illustrate how clusters could be provisioned during that framework that we will talk about. The second piece of Nephio is a set of what I call machinery that enables those use cases and enables that cloud native automation. So as such, so Nephio has actually two phases, if you will. One phase is the use case, right? The second phase is actually the machinery to accomplish that use case. And as I mentioned in the beginning, the machinery is not constrained to the use case. So there are specific pieces that are specific to that FreeFive-GC, but there are a lot of parameters that we are building that can be used, for example, to deploy a database, right? Or a primitive that is completely not limited to a network functions, right? And you will see already I'm using some terminology here. So we're using in that what I call KRM. So KRM is it stands for Kubernetes Resource Model, right? So we're using the Kubernetes API machinery as is, and we are extending that with a set of parameters. So for example, you see here the mention of packages, right? So I'll explain that in more detail. So it's a construct that natively at the moment is not existing inside of Kubernetes. So that's a primitive that we have been extending Kubernetes with to be able to accomplish this, right? You see controllers, that is a native primitive, but we also consume KRM functions, right? That can be run as a serverless function, right? To accomplish something. And those can run either in a container, but can also run as a WebAssembly element that just executes something and achieve a certain task, okay? So two things, Nephio is use cases. Second is machinery, right? So keep that in mind. I'm using the FreeFive-GC, so network functions, to illustrate the machinery, but you will see that you can actually leverage that in other environments, okay? Now, to give you some context of the environment, so most of the people here familiar with telco landscape, I'm assuming, or not? Because if you look to Nephio, we are looking at a fleet of elements. So I mentioned already, we have multiple clusters. So we operate in an environment that have multiple clusters. So for example, if you look to the radio in a 5G, you can have like 10,000 sites or depend. So there is a huge amount of sites on which that get deployed or can be deployed, right? So you see that that scale, that automation framework has to support those type of environments, right? So it can be small, but can be fairly large, right? And so that gets a set of challenges that we have to accomplish, and that's what we are addressing within Nephio. The second thing that you see, and one of the reasons Nephio exists, this is an important element. I mean, as a vendor, we have been used to develop platforms that are completely what I call a black box, right? So everything, hardware, software, everything was packaged together and was actually used to deliver those applications, right? And why did we do that? Because we had very high performance, there was a lot of scale, there was a lot of, let's say, performance and availability requests to make that scalable and highly performant. But what you see is we are coming into a world of disaggregation. So these days, these environments will be built on a generic cloud computing environment. And you see that there is a complete decoupling between the app and the infra. Now, if you come from a world where you have been in control over everything on the planet, and now you have to move to an environment where some of these information is delivered by someone else, right? And you don't have full control over it. How do you do that? So what you see, and one of the challenges that you see is that every vendor has its own way to do that. So one of the things that we are trying to do also in Nephio is try to standardize that decoupling between that infra piece and the application. Because what you see is that in order to develop and deploy that at scale, there is a number of various roles and responsibility in organization that are involved to deliver that, right? So as such, a network function or that application is developed or is delivered or by a certain group of people that own and that are responsible for that application, but the infrastructure is done by a completely different team, right? So we could build an automation framework that doesn't care about that, but the reality is that people consume us in that in an environment where you have different roles and responsibility to achieve that deployment, right? And that's another element where you see that we are doing a lot of effort with respect to the APIs, with respect to the RBAC controls and stuff like that. Who is able to do what in that journey of automation, right? The third thing is that, and that's related to the bullet that I mentioned before, is that every vendor, including ourselves, we have our own specific view of that world, right? And I call it I make the annotation towards the houses, because everyone believes that he builds his own house and the house is the best, right? But in reality, what you see is that operators, they consume not everything from a single vendor, right? So that means that if everybody comes with its own house and with its own thing, and you have to integrate, you see that you have to stack all of these houses together, and that's very complicated, right? So what we are trying to do is actually inside of Nephio is giving you a unified environment on which all of these things run, right? To illustrate it differently, is we are trying to use Kubernetes, and so this is the link towards Kubernetes, as that operating system on which those apps are delivered. So instead of building our own house with our own Kubernetes environment, with our own specific set of tools, no, we are trying to build a generic Kubernetes framework, and then there's a set of apps, think the apps or similar to the network functions that are going to be run on that environment, right? So we are going to use Kubernetes as a native operating system on which all of this runs. And different vendors will use that same Kubernetes framework, right? And we are not going to have a specific one for Ericsson and a specific one for Nokia and so on and so forth, right? So that's the other important aspect. And I make the annotation is similar to our Android world or iOS. So you have a set of apps that are being developed over there that deliver that automation environment, okay? Now, then we come to Kubernetes. So given that there is quite some knowledge in the room, so I'm not going to go into a lot of detail, but Kubernetes at the end of the day at its core is actually a container orchestration system, right? And so what it actually does is you have a set of applications, you deploy that, and it actually orchestrates that across a dedicated environment. And you could say Kubernetes is a cloud by itself for containers. In the meantime, you have solutions that also allow it to be used for VMs and so on and so forth. But basically, in its core, that's what it is, right? And that's where it was born at. Now, and in Kubernetes, we have a concept of a node, which is a host on which something gets scheduled, right? So a container is scheduled in a framework of a pod, right? So a pod can have multiple containers, and there is an API server that makes that happen, and a scheduler, and so on and so forth. So there's a bunch of primitives inside of Kubernetes that make that happen. Okay. Now, then you see, I mean, this is a slide that is being used by many people, but you see that that Kubernetes has been extended in every direction possible, right? So as such, today, you can use Kubernetes to, for example, to set up a VPC or to set up Kubernetes inside of Google or inside of AWS. So in other words, it's no longer constrained to container orchestration. So it's being used by various projects to do anything. I mean, if you look here, I don't know how many icons are on the chart, but it's probably more than 200-300 icons that are on this chart that are doing something, right? For example, in this context, you can, I mean, this was one of the experiments that we used before we jumped on this bandwagon. We tried to see, can we leverage that Kubernetes system, for example, to reach out to physical elements, right? Like in this context, we have a lot of devices which have Yang support, right? Can we leverage Kubernetes to interact with a Yang-based API? The answer is yes, right? And so what you see is that because we have all of these primitives and we have that huge ecosystem, it makes sense to leverage that for that whole automation framework. So that's basically why we leverage in Kubernetes, because you can leverage a lot of activities or a lot of projects that are enabling certain use cases, and you don't have to develop it yourself. You just have to interact with that API. And because we are all using KRM, which is the language, if you will, on how that API system works inside of Kubernetes, that whole integration becomes way easier. Or at least that's our perspective. Okay. Now, at its core, how does Kubernetes work? Actually, there is a controller, right? And it's a very simple building block. So you have a controller that has a sensor. So you get an event, and that controller will do something with that event. And at its core, Kubernetes is an intent-based system. So it basically gets a request from an API. I want this desired state. It looks to the actual state of what's happening for that particular environment, and it ensures that it tries to align that, right? So it tries to align the desired state to the actual state of that system. And if you look to inside of Kubernetes natively without any extension, you see a bunch of these controllers happening. But if you look at it from an automation framework, it's a very nice primitive to leverage for automation, because you get a complete event-driven and declarative system with this, right? And we want to leverage that for the use case that I was talking about in the beginning, okay? The second thing, just to give some context, what is KRM, right? I have a better example actually later into the examples, but it's a predefined, you could say there is a header, right? So there is a header that is fairly standard, and then you have basically a spec on which you can define your own API attributes, and you have a status which are also customizable. But the spec itself, so the metadata in the header, if you will, is a predefined format, and that's the thing that we are leveraging. And that's what we are calling KRM-based system, is basically there is a predefined schema that we are leveraging in order to do a number of things. And why is that important? For example, by having that predefined schema and that all these applications leverage the same schema, integration of the API system becomes way more simpler, because we are all somehow talking the same language, but then you can customize it within a set of parameters, right? And what you see is, why is that ecosystem so big? Kubernetes has a concept of CRDs, right? And CRDs are a way to extend the API with your own schema. So you can take any schema that you want. So for example, one of the experiments that I did was, I took a YANG file of IETF or any device, and you basically build a schema with that YANG schema. So as a result, you now have a mapping of that YANG device inside of KRM, and then you have to ensure that you can interact with it in a declarative way. And as a result, you enable a bunch of use cases, right? So that is the basic primitives that we are talking about. Second, very nice attribute of KRM is it's completely event driven, right? So that means if your state changes or if you get a trigger from something, you can actually see whether the desired state is still in line with actual state and so on and so forth. So you get a very nice set of primitives, which are, in my view, fantastic for when you are looking at automation. Because what you typically see in automation frameworks today is they focus on configuration, but they are not focused on this event-driven system that actually take into account real state that is changing dynamically during that environment. Okay, so these are the base Kubernetes principles that we rely upon to, let's say, develop or deploy Nephio. Now, you can ask yourself what is missing, right? Because you see on one hand CNCF, which has this ecosystem, I don't know how many people, probably 500 different solutions. And then what is Nephio trying to do? So for example, the thing that I was mentioning, the YANG-based interaction, today we don't have something in CNCF that does that, for example, right? So interacting with the YANG-based device is actually something that we would like to have in order to accomplish, let's say, interacting with devices that have that API, right? And that's not constrained to, so that can be BNGs, that can be 5G systems, that can be physical switches, that can be basically anything, right? And as such, what we did in Nephio, we tried to structure this space into 3 swim lanes, if you will, right? On the left-hand side, we have what we call the infra swim lane, which is about infrastructure configuration. So I think of clusters in that space, think of network interconnectivity, and so on and so forth. So these are actually infrastructure that you need to deploy those network functions. The second swim lane in the middle is actually the lifecycle management, which are not focusing on the configuration change. So for example, if you have an app and you want to deploy it, so take for example a database, you want to deploy it and you want 10 flavors of it, or you want to upgrade it, that's what is in what we call the swim lane 2, which is the middle swim lane, where we actually do generic lifecycle operations on such a function, right? And then the third swim lane, which is on the right, is actually the configuration changes onto a running system. And so for example, you want to add a VLAN, you want to change a VPN, or you want to, so in networking space, or you want to add a slice, things like that on a running system. That's what basically swim lane 3 is where you can do that dynamic change. So we basically separated that into various buckets. And as such, that's how we reason and look at those use cases to see what is missing in each of these 3 swim lanes, and what do we have to do to actually extend that. And you will see in the next set of slides what are the things or the primitives that we have been adding in order to make that automation journey easier. Okay. Now, before I go into more details, what is important, and I mentioned it in the beginning, is that whole concept of roles and responsibilities, right? Because when you deploy an app and you need something from the infra, let's say you need a VLAN on a switch to ensure that that app runs, typically that VLAN or that IP address that is configured on that switch is typically done by a different team. So it's typically not the people that develop that app, it's typically done by the infra, right? So you need to ensure that that whole ecosystem takes into account these primitives and the way that people consume you, right? And that has an important effect on how we build that API system and how we package those systems into a decomposable infrastructure that is flexible to accommodate different environments, because also it is like this, that not every operator is the same, right? So we also see that depending on how people are organized, you can see different roles and different responsibility to achieve and accomplish something, right? So the first thing that we saw inside of that whole journey is that there was something missing with respect to the way that that whole automation system works. And configuration as data is a concept that we are using inside of Nephio. And to summarize it, what it means is, so the first thing, if you look native Kubernetes, it doesn't have a version backend, right? What it means that if you add an API or a YAML file, it doesn't keep track of the various versions, right? So that means if you change something, the latest version is what is in the API system. So it doesn't track the changes necessarily, and it doesn't keep track of the different flavors that you have inside. So there is a versioned backend that we are using. The second thing that we use in configuration is data is a package management system. So what is a package? A package is a set of KRM resources. And why is that important? Because that set is achieving something, right? So if you build a package, you basically build a set of resources in that package together that accomplish something. So an example, just to, I think in the next slide is an example. I don't know whether it's very visible, but you see on the right-hand side, you see that is a package. So a package, for example, in this case, this is an example of a network function, right? So you see that you have interfaces. So there is, this network function needs 3 interfaces. It needs a DNN, which is very specific to 5G. So it needs a PLMN ID, right? It needs a pool for UEIP addresses. So what the package does is actually, it's a set of individual resources, but together in the package, they are binded together, right? But the nice attribute of that is we do not have to build an API system for each of these functions. We can actually say, so that interface resource, if you see here, whether it's a 5G system or whether it's a network device or whether it's a BNG or whether it's whatever thing that needs an interface, we just reuse that same building block. So that KRM resource that you see inside, we can just reuse for anything. And rather than building a new API that aggregates it and tries to do it, we just say this package contains a set of resources, and the fact that they are together in the package means that they are binded somehow together. And that also allows us to go very quickly, because that means we don't have to have various conversations on how that API system and how the best structure is to accomplish these things together. We just need to ensure that the basic building blocks that we need, we have to define, and then we just consume that system, right? And the second or the third thing that actually configuration as data does is it allows us to have a set of functions or controllers that act on that package, right? Because what you see is that sometimes you need to change, so that parameter is an input and needs to be used. For example, I need an interface. That interface needs a VLAN, right? I need to allocate a VLAN, right? So what that pipeline does within the package, it gives you a set of functions or controllers that actually use that data that is inside and then mutate or generate or validate the data that you receive within that package. So as a result, what is nice now, you can actually mutate a data. So for example, you say, I get this VLAN, I need it on this interface. You can actually mutate during that package, and because you have all these KRM resources, you can actually build a completely new resource from the input that you get, right? And these are things that you don't have natively inside of Kubernetes, and we are heavily using that because you get this whole this decomposable piece of software that you can compose together the way you want, right? And what we are trying to do in Nephio is try to build those functions as generically as possible so that we can use it into various use cases. So that's why I said from the beginning, the use case as such is focused on Free5GC. But for example, the interface function, we have already tried it to use it, for example, inside of a cluster, right? Or inside of a switch or inside of a network function. So we can use those things in various resources. And then if we have a library of all of these functions, we can basically scale to do many use cases. So that's basically how you have to look at Nephio. And what you see here in this example is the left-hand side is how that package looked like when it started. And when you go through a whole pipeline, it changes, mutates, validates, and changes the resource or generate new resources that are relevant through that pipeline, right? And I have a better examples on how that works in reality. But that's basically configuration as data. So it's a concept that allows us to mutate, extend, use resources within a package and change that. And the other nice attribute of it is that during, so when you have a package as an input and you generate new input, you keep track of all the changes. So that means, let's say, what we call inside of Nephio, we have something what we call a blueprint package. So it's the source or where everything starts from. Now, let's say that for whatever reason, we have a new software or we see that there is a security vulnerability and we have to update that package for a second revision to accommodate for that change. What happens actually is that we just change the new revision and that whole hydration, if you will, is exactly the same. So we always keep track of that whole chain of how each of the steps that have happened during that pipeline and to keep track of the changes and be able to do changes at scale. And that works across the whole fleet of the environment that I was talking about. So now, how does Nephio look as an architecture, right? Because so far I've been mainly talking about the pieces of the puzzle. If you look to Nephio as a system, how we architected it, how we put the pieces together is we have a concept of what we call a management cluster, right? And we have what we call workloads, right? So think of those 10,000 sites of the radio, right? So each of them represents a bubble in this. And that's also can be what we sometimes call a runtime, right? So we have like a management plane on which we do stuff. And then we have runtime or workload environments, which gets then the actual running application that is going to accomplish something, right? Now, also to make a bit of an analogy towards Kubernetes back, right? So in Kubernetes, what you typically have, you have a cluster, right? So Kubernetes natively works within a cluster. And as I mentioned before, there is nodes. So nodes are can be delivered in bare metal or VMs and stuff like that. So a node is a unit on which you can schedule containers, right? Or pods in the case of Kubernetes. So they schedule pods. And then we have what we call deployments or stateful sets. So depending whether you have a stateless or stateful application, you basically schedule that unit across that fleet, right? So you basically have, and that's what, in essence, what Kubernetes was born with, okay? If you make the analogy to Nephio, replace node with cluster, right? So you have a cluster, which is the unit on which you schedule. You have network functions, so the application. So because a network function can consist of multiple pods, right? And we schedule them across those clusters, right? So that's kind of a little bit how the use case for Free5GC or for is working right now. We have a package from the beginning, and we schedule that across the fleet of clusters. So for example, we can say schedule it only here or schedule it there, depending on the parameters that you give it as the input for your automation framework, right? So there is a lot of analogy that you see here on how Kubernetes works as a base system, but it doesn't have this concept of fleet management, right? So that's something that we have added into it. And then if you put that together, right? So you basically have that management cluster and those runtimes. On that management cluster, we have a set of controllers and functions that are running to accomplish that automation job, right? And so what are those things? So typically what we try to do is we try to start from what we call a blueprint package, right? As you saw before, a blueprint package consists of a set of KRM resources like the interface, I need an IP address, I need a VLAN, I need, so those type of things. And then what you see is that we schedule that package towards a certain environment, right? That can just be, I need one, or I need it everywhere, or I need it I need it regionalized, right? So you basically say, I want to fan out based on a set of criteria. So what actually then happens is we replicate that package, but what you see is during automation, that environment on which that gets scheduled has potentially specific parameters, right? So what we are doing during that process, we are actually propagating values towards from that specific environments inside of that package dynamically, and then we mutate it further to accomplish that automation job, right? So that's kind of a little bit how Nephio works. And then we also try to, and that was the feedback from a lot of customers and service providers, we try to give them the hooks to validate and test these outputs before they actually go to the runtime, right? So in other words, you can, people talk about digital twins and stuff like that. So you could actually say, I get a new, let's say, output, but I want to validate that that configuration that I'm going to apply to that environment actually works, right? So you can actually build a hook to say, okay, I scheduled this to a system, you run it through a CI/CD pipeline, and then you can actually validate before you go to the runtime. So all of these components are actually inside of the system to achieve that. So now, what are those primitives that we use to accomplish that? So the first one is what we call a package variant. So typically you start from a package, and because everything is versioned, right? We clone that package, but you potentially can change parameters, right? So for example, I want to deploy this onto this region, so you get the regionalized parameters. So that package will, so some of these parameters, and you can control how you do it. You can actually mutate or that parameters that are locally or giving you the context on where it gets scheduled, get then added into the package based on that function that you set up within that package itself, right? So you basically, you can see you can build very decomposable constructs fairly easily to achieve that. And we, for example, when we started Nephio, the use cases, we started looking at 3.5GC, and then we said, okay, but we also need clusters. Can we use the same primitives to basically deploy clusters? And we used exactly the same construct just to prove that the machinery that we are building can be reused for different use cases, right? The second primitive that we built is what we call a package variant set. The way I would describe it, it's a for loop with some input, with some context. And so you basically have a scheduler that takes that package with that parameter. You actually, so you do that that fan out that I was showing to basically deploy this across a fleet of environments. So that's a whole thing. So that's what the package variant set actually does. So you take a package as the input, you schedule it towards various environments, and then each of these parameters that are, let's say, localized for that environment gets added or mutated within that package. The third thing that we do is when we go through that whole process, and that also comes to the factor of that roles and responsibility. You see that typically, for example, that interface, right? So that network function says, I need that specific interface, but then the infrastructure person needs to allocate a set of resources that are needed for that interface. So what that choreography does, it actually allows you to achieve those type of tasks independently, but together they achieve a certain outcome. So that is actually nice, because you actually have like this independent function that have no clue that they are working together inside of a package, but they together, because of the composition that we have or the choreography that we have, actually achieve that. And so the way we do that is we leverage, let's say, the primitives that are within the Kubernetes ecosystem of conditions. So for example, if a function run, you can actually say that I need more work from you, and you can actually request work to another function that is then going to act. And so that whole pipeline gets automatically triggered and figures out all the dependency automatically without you having to figure out, okay, how does each of these things work together? So it gives you a very nice way to accomplish a set of tasks independently without creating a lot of logic on how it all works together, right? So that's how you have to look at it. You probably have to look at this in more detail on how it looks like, but what it's nice is you don't have to build by yourself that whole dependency tree on which thing is dependent on what. It sorts itself out, right? Similarly, on how Kubernetes works, you have a set of independent controllers that tell you, I want an IP address, and the person that allocates IP addresses is going to act and is going to allocate that thing, and he's going to then make it known, and then something else will trigger. So that whole pipeline, as you see, is something that basically happens automatically. So to give you some context, so what did we deliver in R1? So R1 is a release of Nephio that just was done, right? So all of the primitives that I was showing you here are actually delivered, right? So all of these functions are available in open source. And the use cases that we are able to accomplish with that is deploying a free 5GC across that whole fleet of that environment, right? We are able to do changes to those configurations. So basically those packages, when you say, I have a new revision, I have new changes inside of them, they will automatically hydrate and stuff like that. You can do changes, upgrades and stuff like that. Plus we also have provisioning of all the networking and the clusters and stuff like that. So there's a whole bunch of use cases that we enabled within the R1 release in order to accomplish some of that task, until the point that you can actually make a call, right? Because it all comes down to making it work and basically achieving a call or a data plane packet across that whole infrastructure. So with that, I think, so lunch is coming in, so it's right on time. So I hope you get a little bit of a better understanding of what we're trying to accomplish with Nephio. So here there's a bunch of links if you want to go into more details. And given that we have still some time, I think if there are questions, I'm happy to take some questions. Thank you. Charles.
Okay. Charles Eckel. First of all, thanks for a great talk. Really enjoyed it. And one of the things we were just talking about earlier today, which I'd like to get your insights on, we do a lot with certificate and certificate management here, and there's the IACME working group. And I was just wondering, within this environment, if Nephio, how does Nephio deal with containers and with renewing certificates, especially perhaps short-lived certificates? Is it kind of like and maybe this is a deployment option, but whether to tie the life of the container to the life of the certificate, or does Nephio handle renewing certificates whenever necessary and keep the container running across this renewal?
So first of all, that's something that is natively inside of Kubernetes. So there is Cert Manager, which actually interact with ACME. So to actually generate certificates automatically, right? And that whole renewal process is there. So the way that Kubernetes works basically with certificates, you actually mount that certificate inside of your pods. And if you renew it, you actually, so that volume gets changed. and then the application takes that new certificate into account and leverages it. So the new session, so the ongoing sessions still use the old, right? Because the session has been set up, but every new session that is being set up is going to leverage that new certificate.
When you say new session, is that like a new container that gets spun up, or does the container stay up the whole time?
The container stays up, right? So you have a volume so that certificate gets injected inside of the pot, right? And then the application uses, or depending on how it's written, you can also, but there are, let's say, basic primitives inside of Kubernetes that allow you to reuse that certificate on the fly.
Okay, great. Yeah, thank you.
Hi, Nacho from Telefonica. I was wondering, have you considered using Helm for managing the packages?
Yeah. Okay. Yes. So that's a hot topic inside of Nephio, and I did not go into that detail so far. But if you look, configuration as data is a little bit, so they are competing with Helm a little bit. So, or let's say attacking Helm, if you will. And what is, let me explain the reasons behind, right? If you look to Helm, for those familiar, Helm is actually is a mechanism which you have like a values.yaml file. Right? So they basically deliver a new API, and then through a set of templating and rendering systems, you actually generate a set of resources, right? So if you compare that with configuration as data, with the package system, the difference is that you don't have to build a new API, which is the values.yaml file. And so it's the same API, and you have a set of functions and mutators to basically accomplish what Helm does, right? So why are the configuration as data people doing that? Is because you get native KRM. You don't have to build a new system to mutate something, right? So you don't have to build a new API that is not native Kubernetes. Right? Not native KRM, and now you have to manage that whole lifecycle, and you have to have a system that does that, and so on and so forth, right? So that's the reason. If you look to configuration as data versus Helm, it's not that they say it's bad; they say that's a different behavior. Now, what you see in the industry is that configuration as data is brand new, and Helm has been used or around for I don't know how long, because it was even there from the OpenStack days, right? So what you see is that Helm is used a lot by actually every vendor today has a Helm chart one way or another to accomplish that. So we are looking as we speak to integrate Helm within the whole ecosystem. Now, what I can tell you, the latest discussion that we had on that topic, the main use case or the main requirement that we get is the ability to reuse Helm charts that a vendor already has in that whole ecosystem, right? Now, what it means is actually that it's needed at the end, because the vendors don't want to change those Helm charts either in order to leverage the benefits of the system that I showed here, right? What it means actually is that that Helm chart will be used at the latest stage. And so what we will do, or what we plan to do inside of Nephio, is to render that whole specialization, that package, towards the values.yaml file. That is what the vendor delivered, you see? And so we don't have to change anything. We just have to ensure that we can render that whole thing. So that whole system that you saw before will not change. We just need to make a plugin at the end. And typically those plugins already exist. We just have to use some of these things to leverage that values.yaml construct and ensure that we, let's say, hydrate those parameters towards it and then deploy it as is. And that's how we are looking at supporting Helm within the Nephio framework.
Okay, thank you.
Okay. Thanks. Any other questions? Yeah.
Hi, my name is Ted Kuo from National Yangming Jiaotong University, where is the home of Free 5GC.
Okay, perfect. Thank you. Nice to meet you.
Yeah, so it's very nice to see that have been chosen as one of the use case. Question is, we are also working on manual how to deploy application to MEC area.
Yes.
I wonder that if Nephio has a similar discussion before, so that maybe we can jointly work together on that one.
Yeah, so if you look to the approach that we are using in Nephio, it's a bit of an alternative to the Mano frameworks. And because we leverage the full, let's say, benefits that Kubernetes gives us, right? Because it has a whole we don't need to have a lifecycle manager because the controller that I was showing before is a lifecycle manager on its own.
Yeah.
And so what you see is that actually the Nephio approach is basically a different way to achieve what Mano tries to achieve,
yeah.
right? So, and what we are trying to prove right now with Nephio, I think, is to try to show you that it will be faster and quicker to leverage that approach. Plus, you can leverage that whole ecosystem that I was mentioning before.
Yes, I think that's in line with what we thought about.
Yeah.
We start from the OSM because it was a tool over there already. Yeah. So, but once the Nephio comes up, we are thinking about there's some possibility of how to deploy this application in a more efficient way toward the MEC, distributed MEC environments.
Right. Yeah. Yeah. Same. Yeah. So we will work. So that's one of the use cases that we are going to focus on next, most likely, is Mac and radio and stuff like that.
Okay, that's great. So, and anything we can do to help.
Yeah.
Okay,
let's talk offline.
Sure.
Yeah. Thank you. Any other questions? If not, thank you for your time, and I hope you look at it. Was it okay?
Yeah.
Was it understandable? Thanks. Okay.